So hello everyone. Today I want to share with you guys about the application of the wireless sensor in the structural health monitoring system. So my name is Jia Hao and I am from the CEE department. So my sharing will be outlined in three parts. At first, I will introduce about the structural health monitoring system, and then I will talk about the wireless sensor, and finally I will talk about the application of the wireless sensor in the structural health monitoring system. So to begin with, structural health monitoring system has been early adopted in the airplanes and machines, which is used to monitor their working conditions. So some guys may ask, what is a structural health monitoring system? So just imagine you want to conduct a body check when you go to the hospital. The doctor may check your body and tell you whether your body is good or no. So this is quite similar to our structural health monitoring system. We apply the sensors on our structures and we monitor their working conditions, and we also analyze their working conditions. And our analyzed result may provide the forecast for the condition of the structure, maybe whether there is some potential failure or no. So traditionally, we use the cable sensors in our structural health monitoring system. There are many pros about the cable sensors. For example, the accuracy of the cable sensor is quite high, and the reliability is also very high. But there are also some limitations about cable sensors. For example, the installation cost and the maintenance cost of the cable sensor is very high. Imagine you want to install a sensor on a long bridge, and you need lengthy cables. So the high cost of the installation and the maintenance also limit the application of the cable sensors in the dense array of structural health monitoring systems. So some researchers propose the wireless sensors. Compared with the cable sensors, wireless sensors has many advantages. For example, the installation cost of the wireless sensor is very low. Imagine you don't need lengthy cables. What you need is only a small antenna, and this antenna can achieve the data transmissions. So the installation cost of the wireless sensors is quite low, which means we can conduct easy distribution of the monitoring network. There's also some limitations about a wireless sensor. For example, the energy consumption can be a problem. So this is the actual engineering case about the application of wireless sensors. This is a Jindo Bridge located in the South Korea. And in the structural health monitoring system of this bridge, we use 17 sensors, wireless sensors. And among the 17 sensors, there are 8 sensors powered by the sonar pair. I will talk about this later in our presentation. So this is a sensor location map for this bridge. And we have mentioned before that the energy consumption can be a limitation for the wireless sensor. So some researchers want to know whether we can harvest energy to power our sensors. There are some energy harvesting methods. For example, some researchers may ask whether we can transform the sonar energy to power our wireless sensor, or some researchers may want to ask whether we can transform the vibration energy to power our wireless sensor. So in this case, the author used the solar panel to power our wireless sensors. This figure shows the charging status of the solar rechargeable batteries installed on the wireless sensor. we can find that the charging status of the batteries is quite stable and constant, which means the solar panel technology is feasible in the wireless sensor. And you can also find there is a black line, a black inclined line in this figure, right? This because this solar panel is installed on the back side of the deck, so it cannot receive enough sonars. So we have also mentioned the data reliability of the cable sensors is quite high, right? But here we conduct a comparison between the result of wireless sensors and the wireless sensors. This is a model identification figure. Actually, we use a model identification to monitor the dynamic property of our structures. So from this figure, you can find there is a very good result matching between the wireless sensor and the wired sensors. So this proves that our data reliability of the wireless sensor is also very high. And this is an industrial case in China. Here, we install the wireless sensors on the bridge to monitor the deformation of our deck. And you can find that from the 4 a.m. to the 8 a.m., there is a sharp change in the deformation of our deck. So this is caused by a very heavy traffic jam. So in this case, we can find that our structural health monitoring system powered by the wireless sensor has already been applied in the industry and even achieved the real-time monitoring. So to conclude my presentation, the employment of the wireless sensors can decrease the installation and the maintenance cost of the structural health monitoring system, and the wireless sensors can be used in the dense array of the network nodes. And also in this application, we can find that the feasibility of the energy harvesting method to power our wireless sensors is approved. And finally, the monitoring result of the wireless sensor is also very reliable compared to the cable sensors. So that's all for my presentation. Thank you.